Rocks are fascinating because they reveal Earth's geological history. They are classified into three types based on their formation. Igneous rocks form when magma cools deep within the Earth or through volcanic activity and crystallize. Sedimentary rocks are formed from the accumulation and compaction of mineral and organic particles. Metamorphic rocks are the transformation of existing rock types due to heat, pressure, or chemically active fluids. Understanding these classifications helps us appreciate the diverse processes that shape our planet. Rocks have a subcategory known as minerals. While all minerals are rocks, not all rocks are minerals. A mineral is a naturally occurring substance with a specific chemical composition and crystalline structure. In contrast, rocks are mixtures of minerals that have not been separated into crystalline structures. Minerals can develop in any rock type: igneous, metamorphic, or sedimentary. Generally, minerals are deemed more valuable than rocks. Why collect rocks? Let me share my reasons. I appreciate their beauty and intricate patterns. After polishing them, they can be displayed and admired. All stones are unique. No two are the same, much like snowflakes. Discovering and collecting new and interesting rocks is thrilling. From an educational perspective, rocks narrate the story of our planet and help us understand our place within it. Here are some methods for identifying rocks and minerals. First, research the geological history and types of rocks and minerals found in the area you plan to visit. For example, I enjoy exploring the Pedros and Granite Mountains in Wyoming. The region's complex geological history has resulted in the presence of many unique rocks and minerals. Among these are Genesis stones, serpentinite, and various types of volcanic rocks. Additionally, the mountains are home to semi-precious and precious minerals, including agates, opals, nephrite jade, and carnelian. Nephrite jade is not rare in this geographical area. However, I would not expect to find jadeite jade in this area, as the geology is not conducive to its formation. The best times to search for interesting rocks and minerals are in the morning or evening. During these times, the light is scattered, softening harsh shadows and creating even illumination that enhances the colors of the rocks and minerals. Most minerals have a smooth, greasy texture. After I bring my rocks and minerals home, I spray them with water to highlight their colors, grain patterns, and crystal forms. I then use a magnifying glass and consult a reliable rock and mineral field guide to help identify them. Looks can be deceiving. Many green rocks and minerals can be easily mistaken for nephrite jade. For instance, serpentinite is often confused with nephrite because of their similar metamorphic origins, and both are classified as rocks. Both are commonly found in the same geological regions. Serpentinite is often referred to as nephrite's sister. To further complicate matters, not all green rocks are nephrite or serpentinite. Here are examples of other green rocks and minerals that can be mistaken for nephrite jade, aventurine, prehnite, mica, morganite, and the highly valued jade, also known as real jade. I will focus on identifying the nephrite and serpentinite samples I collected during my recent expedition to the Granite Mountains. Upon examining the mineral grains, I observed that these two rocks exhibit a broken-up foliated grain pattern, which nephrite jade does not have. Next, I will utilize the Mohs scale of hardness as an identification tool. The Mohs scale of mineral hardness, developed by Friedrich Mohs in 1812, is a qualitative scale used to measure the scratch resistance of various minerals, ranging from 1 talc to 10 diamond. The Mohs scale is a surprisingly accurate and cost-effective method for identifying minerals in some types of rocks. However, testing rocks can be challenging because they are mixtures of minerals, each with a different degree of hardness. As a result, the Mohs scale becomes less effective for identifying rocks. Although both nephrite and serpentinite are classified as rocks, they are listed as testable on the Mohs scale of hardness. Nephrite is rated 6 to 6.5 on the scale, meaning it can be scratched by a steel file, but not by glass. In comparison, serpentinite has a rating of 2.5 to 6. This means copper should leave a mark on it. However, due to the broad range of hardness, I do not consider this scale an accurate method for testing serpentinite. Here are 3 quick methods to distinguish between nephrite and serpentinite. When struck with a rock hammer, nephrite produces a clear, ringing sound similar to a bell, while serpentinite does not. If your specimens are similar in size, weigh them. Nephrite is denser and therefore weighs more than serpentinite. Most serpentinite exhibits slight magnetic properties. When placed near a magnet, serpentinite will show a slight attraction, whereas nephrite does not have this characteristic. After conducting these tests, I am confident that the two specimens are nephrite, while the other two are serpentinite. After identifying my rocks, the next step is to polish them up. Thanks for watching. Please subscribe. Until next time, bye.